In this video, we are going to provide hints for one of the practical problems in differential equations. We're going to start off with the Polya's model. As usual, this is the model that we are going to use to help us to solve problems whenever we are stuck. According to Polya, the first thing we do is to understand the problem, devise a plan, carry out the plan, and eventually check and extend. And at every stage of the problem solving, we can always go back to the previous stages. In this particular practical problem, we have an object whose temperature is higher than that of its surroundings, and we are interested to find out how the temperature of this object is going to change with respect to time. So first of all, we try to understand the problem. The problem says that the rate at which the temperature of a hot object decreases may be taken to be proportional to the difference between the temperature of the hot object and the temperature of its surroundings. To help us to solve the problem, the question defines some symbols to help us to form mathematical equations. For instance, we are told that θ is the temperature of the hot object at time t, and that the temperature of the surroundings has the constant non-zero value θ0. The information allows us to write down dθ dt is proportional to θ minus θ0. This comes from the very first sentence of the problem. We know that dθ dt is proportional to θ minus θ0. With this piece of information, we are almost ready to express the differential equation. The things that we need to consider though are, number one, should dθ dt be positive or negative? Should the temperature of an object, which is hotter than the surrounding, be increasing or decreasing with time? Secondly, should θ minus θ0 be positive or negative? By considering these two questions, you should be able to write down the differential equation. The next part of this question requires us to find the general solution of the differential equation. The plan is, since we have found the differential equation relating the dθ dt and θ minus θ0, question basically requires us to solve the differential equation found in part 1. The hints would be: separate the variables first and integrate on both sides of the equation with respect to time. Take note that k in the equation that we are required to solve actually comes from the constant of proportionality when we first write down the differential equation. The last part of this question requires us to find the value of t when θ equals to 2 θ0. We are given the information that when t equals to 0, θ equals to 5 θ0, and when t is equals to big T, θ equals to 3 θ0. So as with most differential equations problem, this information will allow us to find the values of the arbitrary constants. The plan would be, since we have found the general solution, we are going to use it together with the given information to find the particular solution, and eventually we will sub in θ equals to 2 θ0 to find my time in terms of big T. The hints would be that eventually when we find the particular solution, the arbitrary constant A is equals to 4 θ0 and the constant K is equals to 1 over big T ln 2.